if you see this equation, what you want to do to solve for x is divide both sides by a, right? Okay? But if A is a matrix, and X and B are column vectors, dividing both sides by A, can't be done. There's no division with matrices. Okay? Now, I sort of deny the existence of division in solving equations anyway. I prefer to say you multiply. What would you multiply both sides by if these were just numbers? Like if you got 5x equals 9, what would you multiply both sides by in order to solve it? Well, you'd multiply by 1/5, wouldn't you? Isn't multiplying by 1/5 the same as dividing by 5? You know, look a little bit uncertain about that. Well, that's really, really important. Okay? So, for example, if you got 5x equals 9, you don't have to divide by 5, you can multiply by 1/5. And 1/5 of 5x can be rearranged to 5 over 5 times x equals 9 over 5. And 5 over 5 is 1, so you get x equals 9/5. Right? And you're using associative and commutative properties and so forth over here when you do this. And the identity property, remember hearing about the identity property? What's an identity?
When you're adding by 0 and multiplying by 1.
Okay, that would be two examples. Multiplying by 1 or adding 0. What happens if you multiply a number by 1?
Stays the same.
Doesn't change it. What happens if you add 0 to a number?
Stays the same.
Doesn't change it. Identities don't change things, okay? So you get the identity here and so forth. Now, it's important to understand those properties because we extend these ideas into other types of calculation, including matrix calculations. Okay? One of the most important extensions is matrix calculations. Matrices are extraordinarily important. So here we didn't divide by 5, we multiplied by the reciprocal of 5, right? What's the one number that doesn't have a reciprocal?
X?
Pardon?
No. It's gonna say like a variable.
We don't know that. We don't know that. So,
What's the one number you can't divide by?
0.
That's a number that doesn't have a reciprocal. Okay, 0 doesn't have a reciprocal. Okay, any number but 0 has a reciprocal. And you know you can't multiply both sides of an equation by 0. I mean, you can, but you lose all your information, right? Multiplying both sides by 0 wipes the equation out totally and gives you something that's automatically true whether the equation was true or not. Okay? So, and you want to kind of think of it that way, and you know. Okay, so we've got AX equal B. Well, another way to write what I did here. Okay, if I got 5x equals 9, well, what's 5 to the negative 1? Okay, what do I mean by 5 to the negative 1?
1/5.
Yeah, your laws of exponents, it means 1 over 5 to the 1, right? Okay, so this is the same as this. This is the same thing as this, right? Okay, so to motivate that, I'm going to say that we multiply both sides of this by A inverse. But with matrices, A inverse doesn't mean 1 over A. Now in this example, 5 to the negative 1 times 5, x equals 5 to the negative 1 times 9. Over here, this means 1/5 of 9, and this means 5 to the negative 1 times 5 is 1 times x. There's your identity. You get x equals 9/5. Okay? Now, I said that kind of quickly, but if you multiply 5 by 5 to the negative 1, what do you get? Well, one thing you get is you get 5 to the 0 because you add exponents, right? You don't even have to do 1 over 5. 5 to the negative 1 times 5 means, of course, 5 to the negative 1 times 5 to the 1, which gives you 5 to the 0. And what's 5 to the 0?
1.
Any number raised to the 0 power has to be 1, because pretty much of what I just said, if you just generalize that. Okay, well, I'm just using an analogy here. Okay? There is, if this equation is solvable, there is an inverse matrix. Okay? Now, I could, in 15 minutes, show you how to do an inverse matrix if you know how to solve, say, 3 equations and 3 unknowns. Okay? I could give you a process for calculating the inverse matrix. But, you know, that's part of a linear algebra course, or part of a, actually, it's something that you're supposed to learn at the end of a pre-calculus course, second semester. Okay? I find that 2/3 of all linear algebra class, or pre-calculus classes don't get to that, because it's kind of the last thing you do. But it's not, it's one of the actually easier things in second semester pre-calculus, okay? So, all I'm telling you is there's a reasonably easier than a lot of stuff you've done, way to calculate A inverse. But the easiest way to get A inverse is Wolfram alpha. Okay? It'll do it. Okay? So if you put a matrix in there to the negative 1 power, it's going to calculate this inverse. And, you know, I wrote this down, and I've been talking for a long time with something. A complete lie up here on the board. You got to multiply both sides by A inverse, don't you?
Yep.
So I'd multiplied this side by A inverse and didn't do this one. I pretended to do that wrong so you'd correct me. No, not really. I just didn't write it down. Okay? So you may understand that this represents this with both sides multiplied by A inverse, right?
Yep.
Okay? Well, it turns out that you can use this to solve a system of simultaneous equations quickly. And I'm going to want you to solve a lot of systems of simultaneous equations today. Okay? So you're going to do it with Wolfram alpha, and you're going to really like it because it's really easy. Way easier than writing down the 3 equations and eliminating all the variables. Okay? Because you just type it in, hit the enter key, it calculates for a minute, and there you have it. Okay? Doesn't mean you don't have to know how to solve simultaneous equations. Once you know that, you're entitled to use Wolfram alpha to shortcut the thing. Okay?